little slow on the start here, but section 3.4, exercise 40. Okay, again, we want to find all relative extrema, and we're going to use our, let's see, and that's f of x is x over x minus 1. Again, well, take the derivative, find our critical points, our critical numbers, and derivative, well, it looks like a quotient rule, so derivative at the top is 1 times x minus 1 minus x times the derivative of the bottom, and this is over x minus 1 squared. The function was undefined at x equal 1, and so is the derivative, of course. And let's see, this is equal to 1, that's x, minus x is 0, so we just get negative 1 over x minus 1 squared. And so everywhere this thing's defined, the derivative is negative. Okay, so it's always decreasing. Well, so if it's always decreasing on any given interval that it's defined on, it has no relative extrema. But we'll check that, of course, with our second derivative. Now, at this point, our only critical number is at x equals 1 because f of 1 is undefined. But let's check f double prime of x, which it will also be undefined there. So f double prime is not going to really tell us anything, but this is negative x minus 1 to the negative 2. So I'm going to bring down the negative 2 times my negative x minus 1, then to the 1, and multiply by the derivative of what's inside, which is 1. And, let's see, I brought down a negative 2. I didn't make that negative 3. Sorry about that. And so this is equal to 2 over x minus 1 cubed. And so this is where it's defined. Is sometimes positive, sometimes negative, right? So if we look on our two intervals from minus infinity to 1, we could look at, say, f double prime of 0 is equal to negative 2. And so that's less than 0, and that's concave down. But it's concave down and decreasing. And then when we look on 1 infinity, we could look at f double prime of 2, and f double prime of 2 is 2, which is greater than 0. That's concave up. Okay, but we don't actually have an inflection point because the function's not defined at negative 1. And so we have something, we have a function that's decreasing and concave down. Well, that would look something like that. And then it is decreasing and concave up. That would look something like that, and we've got an asymptote there. So, I didn't do any more to really find anything, but you see there are no relative extrema on something like that. So no relative extrema. Okay, so that takes care of 40.